Welcome back. In the last lesson, we looked at adding a kick to our player and adding damage to whatever it collides with. Now we're going to add what the NPC does when it receives damage. So if we test, we press kick and she rolls over and she falls and then she gets back up again eventually. Kick, they roll over, then after a short time, they get back up again. So that's what we're going to recreate. First, let's look at the animations we're going to use. So for the animation of the falling, we're going to use this one. It's called floating. So if you go to Maximo, you type in floating, you'll get this. So we download, and then we're going to go FBX for Unity as always and download. Now you may be wondering why we don't use a falling animation, because they do exist here. So let's look at them. Now something like this. Now the reason why I'm not using this one is because we actually don't want the NPC to be at this angle. We want it to be face up, and then through physics it will go on its front or back. So this one won't suit our purposes. We could modify it, but it's easier just to use the one that I found. We're also going to need a get up animation from falling. So let's see, get up. I think this one's a bit too exaggerated, a bit too long. I think this one looks good, it's a bit faster, but it's on the back. I think we want to go from the front up, so let's look at this one. I think that looks good. Maybe we can speed up a little bit and remove the fists at the end, but let's just download that, and again, FBX for Unity, download with skin. Okay, so now let's jump to Unity. Now in our animations folder, let's just drag and drop in our new animations. So this is the falling one, and then let's bring in the getting up animation. And same as always, let's select both of them. Let's go to rig, generic, change to humanoid, apply, and then let's expand this out. Let's find the animation, Control D, close that. Same with this, find the animation, Control D. And we can actually just delete these because we don't need them. And this. So let's take a look at these animations, and let's just drag and drop our NPC model into the preview. So that looks good, a bit too high off the ground, so let's just reduce this Y position. So let's go maybe something like that, maybe 0.35, just about touching the ground. That looks good, and I think the rotation is fine as well. Let's just bake this into pose. And we can bake this in the pose too, won't make much of a difference. Oh, this will also be looping, so make sure this is ticked. Let's look at our getting up animation. Okay, you can see the character stuck on the ground there, but you don't want that. Let's see what we can change here. Root transform. Yep, I think that's it. Let's see what animations for. Let's check the rotation. Do we need to bake that? Yep, I think that looks fine for now. So let's just go ahead and add these animations to our NPC animator. So let's go to animator tab, and then we have our locomotion kicking as always. So our floating, let's just drag and drop that in, and let's just rename this here to falling. And we can just leave that as is. Let's drag and drop our getting up animation as well. Now when our getting up animation is done, we're just going to return back to our locomotion state, which would be our idle. So let's just take a look what that animation looks like. Yeah, so let's just fix this fist up now. So we go to our scene, let's select our NPC model with the animator attached. Let's go to this animation tab, and let's look at the getting up animation. Maybe around here we can delete from. Drag across all these keyframes, select all these ones after the line, and just delete them. And now if we go back, our animation ends here. At this point we can start blending into our idle animation. So if we go back to our animator now, and we look at this, scrub through, she gets forward, and then she goes into the idle. So let's just add some extra blending. So exit time, let's say 0.85, and transition will keep at 0.25. If you look at this, it gets up. That looks more natural. Now let's look at our code for this. So we'll go to our scripts, and we'll go to NPC states, and we'll create a new C# script. We'll call this damage state. Let's open this up. Okay, so let's remove this stuff, and let's remove this, and we're going to derive from our non-playable character state. And then of course we're going to have to implement the methods. So quick refactoring, implement abstract class, and let's just change the order of these. So init state should be first, and then will be enter state, and then we'll say update state. Yes, we'll leave the rest. Exit state will be last. Now we need to, of course, add our state key. So state key equals non-playable character controller.npc states dot. Okay, we need to add now our damage to the enums. So we go to our non-playable character controller. Just here, we can just add damage. We go back to your damage state, and we'll say dot damage. Okay, so let's actually go back to our NPC controller and let's add the interface of iDamageable, same as we added on the crate in the last lesson. So we just go with this and then implement interface. If we scroll down, we should see that here now. So on damage, the NPC doesn't have health, so we're not actually going to use this damage amount. But on damage, what we want to do is exit the current state and then go to our damage state if the NPC has a damage state. So we can just say if state dot contains key, and then NPC states dot damage. Then we'll just sort of do this, but for our damage state. So actually, let's just copy and paste this. So our current state, we need to exit, and then our current state key is going to be NPC states dot damage, and then we're going to enter our damage state. That's it for now. And let's add some functionality to this. So I think the first thing we'll add is the tipping over. So when the player kicks, there's a bit of force added and the NPC moves over. So let's look at some variables here that we're going to add. Let's say serialized field float force amount. So this would be how much force is applied when the player kicks. And that'll do for now. And then on our enter state, we want to make sure that our rigid body is not kinematic. So core.rb.is kinematic equals false. And then we can just make sure that when we exit the state again, it is kinematic. So let's go down to exit state, and then we'll say is kinematic is true. And let's also add the force applied here now. So core.rigidbody.add force. The way we'll calculate the force is by the direction of the player. So we're actually applying the force in the right way. So what we're going to do is add an extra parameter to our iDamageable interface. So we go to tools folder and then interface. Here now we're just going to add a transform, not transaction, transform. Then we'll say attacker transform, and we'll just default this to null. If we do this, then we don't have to provide it every time. So something like the crate doesn't need a direction, but attacking an NPC will require a direction. So actually then if we go to our damage collider script, we can now say on damage, and then we can just provide this dot transform or just transform. Now if we go back to our NPC controller, on the on damage now, let's just add the transform attacker transform, and then we need to calculate a direction here. We also need to add it to the core because that's what we pass through then to our states. So let's go down here to the core and let's say public vector3, and we'll call this attack direction, and yeah, we'll just default it to vector3.0. And now here we'll say core.attack direction equals, so it's going to be from our own transform, so core.mTransform.position, and then yes, it'll be minus the attacker transform.position, and we'll normalize that as well. So now if we go back to our damage state, and then here for add force, we can just say core.attack direction, and we'll just multiply that by our force amount. Okay, I think that should be fine for now. We can actually test this. Let's just remove these things first so we don't get any warnings. And then for this, we're going to have to return something. So let's say return non-playable character NPC states dot none. Now let's go to our game. Let's see what error we have here. Double click on this. We see here we're not providing this. We'll say transform attacker transform. Spell it right. And of course, we're not going to use this for the actual crate, so it doesn't really matter. Let's go back, let it compile. Now, if we look at our NPC, we need to add this state now. So add damage state, and let's just drag it up so it's beside the rest of the states. And our force amount, so while testing I know that this needs to be high, so let's say 50, and let's go now and test this. Hopefully there's no errors. Okay, let's go up and kick. Okay, so she's sliding but she's not rolling over. Let's see if we can kick her the other direction. Okay, so that's working, but she's not rotating. I think I know the reason why. If we go to the rigid body, yeah, we've got the position or the rotation on the X and Z frozen. We also have the Y frozen. Since we use it as kinematic most of the time, we don't actually need any of these constraints. So let's just untick these and let's try again. Okay, walking as normal, not falling over because it's set as kinematic. Let's go over and kick. And there we go, rolling over now. We kick again. This is the kind of behavior we want. Of course, there's no animations at the moment. So let's just simply do that now. So let's go to our damage state and then we'll say core.animator.crossfade and fixed time. And then I think we called it falling. We'll double check that in a second. And we'll just set the crossfade time as 0.25f. And let's just check we named that right. Yep, falling. So let's try this now. Blocks. And there we go. That's the way we want it. Okay, so now let's look at the logic for getting back up. Let's go back to our damage state. Let's just create a new method. We'll say void get up, and we're going to need a timer. So we'll say timer on ground timer equals new timer. And let's just make sure we add some time for this too. So serialize field float time before get up. And then here we can just simply say on ground timer dot start timer, and then it'll be time before get up. And then on our update, let's get our delta. So float delta equals time dot delta time, and then our on ground timer dot tick delta, and then if on ground timer dot is greater to 0, so actually is not greater than 0, then we want to get up. So let's just remove this, and then we'll call our get up function. So let's have a think about this. NPC gets up and needs to have a rotation and a position. So I think simply enough for our rotation, we can just say quaternion target rotation, target rot equals quaternion dot look rotation, and we'll just make this our M transform. So let's actually just add the core as a parameter here. And then we'll say core dot M transform dot forward. And then of course this is going to have rotations on the X and Z value. We just want the Y because it's going to be stand up straight now. So target rot dot X equals 0, and then target rot dot Z equals 0. And then we can just say core dot N transform dot rotation equals target rot. Now let's set our position. So same thing, vector 3 target pause, target position equals, now I think I want this to be the center of the capsule collider. So the way we'll do that is we'll add a transform. Let's make it serializable up here. Serializable field transform, and this will be the midpoint of the model. So midpoint transform, and then we'll create a new method for that too. So we'll call this void, will be void actually, it will be vector 3 get midpoint, and then this will equal the return value of that. So get midpoint, and then let's just do a ray cast from that point. So ray cast hit, let's capture the hit and it was called hit, and then if physics dot ray cast, and it's going to be the midpoint dot position out hit. We need to add a direction, so that's going to be vector 3 dot down. Then we do your out dot hit, and then let's change this as it's supposed to be our midpoint transform. Then we want to add a layer mask. So these are the layers we're going to check for grounded. So we can add that too as a parameter. So serialize field layer mask, and then ground layers, because we don't want the NPC checking for its own layer or the player layer, so we can change that through the layer mask. And then let's add that here, ground layers. Now, simply, if this returns true, as in this raycast hits something, then will this return hit that point, and then if not, will this return vector3.0. So target position equals midpoint. Now we don't want it to be vector3.0 if it doesn't hit something. So let's just say that if our target position equals vector3.0, then our target position will just equal our core.mTransform.position, and this should be equals equals. Now we can just simply set that now, core.mTransform.position equals our target position. We also want to make sure that physics aren't being applied here while the NPC is getting up, just in case the capsule collider rolls over again. So let's just say core.rigidBody.isKinematic equals true. Okay, so get up, we need to add our core here. And I think this should be good for testing. One thing I can see already will be an issue is the on-ground timer greater than 0. This will keep being called. So I think we should just create a boolean as well for getting up. So bool is getting up, and on our enter state, we'll set that to true. That's getting up equals true. And then we'll do this while our on-ground timer is greater than 0 and you're not getting up. So is getting up. Yeah, so this would actually be false. You're falling first and then you're getting up. And then in our get up method, we'll just say is getting up equals true. Let's try this now, see how it goes. Let's look at our NPC, our midpoint, let's add that. So let's just add, create an empty, let's call this midpoint. Let's bring this up to maybe about here. Let's put the midpoint, so it looks to be about 1 on the Y. And then we'll drag and drop this into the midpoint transform. And then for our layer mask, we want everything except our NPC and our player. I think everything else should be fine. And our time before getting up, let's make it 3 seconds. Let's press play and kick. Okay, so that worked. She's stuck in that animation. We can fix that in a second, but now the collider's back where it should be. If we kick again, it happened again. And after 3 seconds, she goes back up. Make sure we hit the collider. We can kick and it keeps going into the damage phase, so that looks good. Let's just fix these animations now. So we've already added that animation getting up to our animator. So if we go to our code, and then, yeah, just in this get up method, we can say core.animator.play, and then it's called getting up. Let's just copy and paste it here so we don't do it wrong. And that should be it. Let's try this now. Kick. Falls over after 3 seconds. Gets up then. I think we can trim that animation a bit more, but I think it's working. Falls over and then gets up. So let's just trim that animation like we did before. Select our model. Let's select the getting up animation. And I think we can just do it from here when they actually start getting up. And then let's just drag all these frames, delete them, and then we'll hit Control A and drag all the rest of them to the start. So we'll make sure that number at the top is 0 now, and then get up. Let's try this again, see how this looks. Kick, fall over, 3 seconds, get up. Yep, that looks much better. And she falls in the correct direction as well from where we kick. So I think actually our spawning isn't correct. So let's take a better look at that again. So physics.raycast, we do it from our midpoint was our position. Our directions vector3.down, out.head, ground layers. So I think yes, so for what we have in ground layers here should actually be the distance of the raycast. So I think we'll just make it something like 3. It's probably a bit too much. And then ground layers, that should be correct now. If we go back again, it's the correct overrides. So hover over, yep, there we go, head info, max distance, layer mask. So yeah, let's just change this to 2. And let's go back, try it again. And there we go. That looks much better. Great. Now the last thing we need to do, as you can see, she just stays in this state now. We don't have any exit conditions set up yet. So we know we want her to return to her default state once she gets up, but getting up is based off the animation. So let's go and add a parameter here in our animator. Let's say bool is getting up. And then in our locomotion state, we have this change bool status. Let's add another one, change bool status, and we'll say is getting up should equal false by the time we get to here. And then the only way we can exit this falling and getting up stage is getting to the getting up animation. So if we go to our damage state, in our enter state, we can set this to true. So core.animator.set bool is getting up, set that to true, and then let's just capture that as well. So we already have this here called is getting up. So maybe let's rename this in the animator to something else. So is getting up, let's say maybe is on ground. So is on ground, and let's just copy this, bring it back to our script, and let's change this to is on ground, true, bool is on ground. And then just like we were doing before with our is interacting boolean, we can just say is on ground equals core.animator.get bool, and then is on ground. And now on our change state, we'll say if is on ground, then we're going to return our non-playable character controller.npc states. Okay, so now we need to actually return the default state, because if you remember, we have that. So let's look at our controller here. We have this default state. It's not accessible through the core. So let's add that. So let's go here, public NPC state. So let's go non-playable character controller.npc states. Let's call this default state. Then we can also provide this with a constructor. So non-playable character state, default state, and then this dot default state equals default state. Now if you go back up to where we create our core, let's just add our default state. If we go back to our damage state, we can just now say core dot default state and just return that. So for our NPC, we've got it set as the patrol state. So let's just test everything we've done there now. Press play and walk over, stamps, kick. Okay, she's floating. She wasn't knocked over. That's because is getting up parameter doesn't exist. Oh, that's because we changed it in the animator, but we didn't change it here on our change bool status. So we changed it from is getting up to is on ground. Let's add this here. Let's try this again. Walk over, kick. Okay, still floating the game, but not falling over the way we want. Okay, so actually we need to change this to not is on ground. That was our issue. Try this again. There you go. Tap over and then get back up, and now return to the patrol state. And if we go back over again and we kick it again, let's actually kick. Maybe we can change our damage collider to be a bit wider, a bit more forgiving. And this is all working perfectly. And we can kick her while she's down as well, and she moves more. And then she gets back up again. Cool. So we can actually change some of these values here and have some fun results. So let's just change force amount to, let's change to 100. So it's double what we already seen. And let's just maximize this on play. Let's go over. She stops. Kick. I think that looks better. You can even kick her when she's getting up. There's a good bit of roll in there. And let's push this even further. Let's try 500. See what that looks like. Stop and kick. Perfect. No, that's a powerful kick. A little ballerina. Now this is obviously extreme. So let's just bring it back down to 100. I think that was a satisfying kick amount. So I think that'll do it for this lesson. I think we achieved what we wanted to achieve, and it's quite fun. In the next lesson, we're going to go back to looking at our player and adding some more functionality. So make sure you subscribe for that. And as always, thanks for watching.